Hello, and welcome to Fan Request Friday here on Answer Everywhere. Today we're taking a look at some of the Firefox UI code, probably mostly HTML rendering and DOM, stuff like that. But it's probably a huge code base, so I'm not sure how deeply we'll get in. But I got a request to look at how UIs work for the browser. So I have the Firefox web page open. I guess that's nothing so interesting for us here. And I also have SearchFox, which is their source code repo where you can search the code. And I think Mozilla Central is where Firefox is. I'm also noticing some stuff in the chat. So let me look at the current chat. So Adil is asking me to read more Python or Golang codes. Yeah, I could. I don't know if I have any Golang codes scheduled. At some point, I'm going to look at Kubernetes, which I think is in Golang, or at least largely in Golang or partially in Golang. And hello, I'll look at. I think maybe somebody asked me to look at maybe C Python or the Golang standard library. I can do some of that. I have a huge list that I don't have open right now, and I'm not positive all the things that are on it. All right, so let's get to Firefox. Hi, Tat, and let's make sure this chat stays on top. Okay. All right, so in this other tab, I have so Firefox has this description of where things are. So let's take a look at this. Chrome or Chrome, yeah. Chromie. Okay, so Toolkit is, I think, a GUI toolkit. The new toolkit used by Thunderbird, Firefox, etc. This contains numerous front-end components shared between applications, as well as most of the XBL implemented parts of the XUL language. Most of which was originally forked from versions in XPFE. So XUL is like an XML-based GUI language where you describe your UI windows and menus and stuff in XML. And that's a super standard pattern. We've seen that with so Qt or Qt does that. We've seen some of the XML files there. Android at least used to describe their UIs in XML. I'm not sure if they do something else now. And I guess Firefox obviously as well. And then you can think of HTML as like a variant of XML. And so even web pages are also kind of the same sort of thing. So we get this pattern where we've got this XML-based description of an interface that gets rendered by some code. So that's the toolkit. And then somewhere probably under C for Chrome. So there's the Chrome registry used with toolkit. These files were, okay, so if we click on the Chrome registry, so Chrome is the set of user interface elements of the application window that are outside the window's content area. Toolbars, menu bars, progress bars, and window title bars are all examples of elements that are typically part of the Chrome. So the Chrome is stuff like this. So here up at top, we have the title. It says Chrome registration, and then Firefox source docs, and then GNU IceCat. And then the tabs, I guess, would also be part of Chrome. Whatever this bar is called, with the back buttons and the refresh button and the URL thingamajiggy. And this, this stuff over here, and then, it's all the stuff that's outside of the like browsing window. So that's Chrome. A supplier of Chrome for a given window type, for example, a browser window, is called a Chrome provider. The providers work together to supply a complete set of Chrome for a particular window. And we have things like content, locale, and skin, and then we have a registry of some sort. And then we also have DOM. Widgets would be part of UI. But DOM is what I was looking for. Does it help if I do caps? Okay, so the DOM has IDL definitions. IDL would be an interface description language. IDL definitions of the interfaces defined by the DOM specifications and Mozilla extensions to those interfaces. Implementations of these interfaces are primarily, but not completely, in content. Okay, so we'll look at content, I guess. The parts of the connection between JavaScript and the implementations of DOM objects that are specific to both JavaScript and to the DOM are here, and implementations of a few of the core DOM level 0 objects, such as window, window navigator, window location, etc. So let's look at window. This should be the API, but I don't want the API. I want the code. So let's see if we can find it in Searchbox. So the DOM directory. And do we have window? Workers, WebSockets. Those are both interesting, but those are not plausibly part of the UI. Can I search within this folder? I could try window. This might match too many things. This accessibility stuff for Windows. Browser installer. How do I, let's see. How do I just do window dot? Oh, wait. Is this literal dot? Window dot request animation frame. Browser components. Let's see, if I go here, this dot window, and I click on window, go to definition. I can go to the customize mode window. I don't think this is what I want. So let's go back to DOM. Maybe base. What else we have? We have Chrome Web IDL. Maybe Chrome Web IDL is interesting. Encoding file system flex gamepad. How about HTML? IPC should be inter-process communication. Locks. Locks are interesting, but they're not part of the, I don't think that's what people want from the UI stuff. SimpleDB. I'm kind of curious what SimpleDB is. Maybe it's something that like predates SQLite. And then we have the HRXML and XLT and XUL. We'll just kind of poke around here. See if there's a window dot something. DOM. DOM rect. That looks like a rectangle. Let's look at DOM rect and DOM quad, maybe rectangle and quadrilateral. There's a fuzz test. It's good to see fuzzing. Image tracker. I guess we'll skip image tracker. Navigator. Let's look at navigator.h and node info. These are, I'm just clicking on things that seem like, you can't always tell from the name. But they're named like things that I've seen in other code bases. So I'm just thinking, well, maybe they have something to do with rendering the UI. But what I really wanted was window, which will be at the bottom, right? You have the XPath generator and window features, window destroyed event, window proxy holder, visual viewport. We'll look at the visual viewport. I'll look at window features. I can't really find window. I guess I'll look at XPath stuff. Oh, and tree walker. That looks fun. UI direction manager. Okay, so we'll just see what's here. Oh, style sheets for sure. All the things. Static range, shadow root. Scrolling metrics. Scrolling metrics. Kind of want to know how selection is done, but let's also look at scrolling metrics. So let's see what we have. So here's DOM rectangle. We get this, like at the top, you get these codes that set up like editor settings like Vim, which is not so interesting. And then we get to the real code, and we're including algorithm. It's good. And just some it's pretty basic stuff. It looks like we're including. We've got some class like JS object, presumably JavaScript, context, and NSRect. And we've got this global object class that's being, I guess, defined so that we can reference it. And a DOM-rect init, DOM-rect read-only. NS-decal cycle collecting I supports. Cycle collect. This might be garbage collection stuff. And the DOM-rect read-only takes a parent, which is of type NSI supports, an AX and AY. This seems to be something, okay, I guess side A, X and Y components, and a width and a height. And yeah, we've got this wrap object function that's going to take a JS context, I guess like a JavaScript context, and then a JS handle, which is a given proto, and it's going to return a pointer to a JavaScript object, it looks like. And we can get the X direction and the Y direction. So it's presumably a rectangle, right? So how would you parameterize this? I guess you need to know if you have where one of the vertices is, then X and Y as lengths would give you a rectangle, would be enough to parameterize a rectangle that's like parallel to the X and Y axes. But I'm not sure exactly what X and Y are, but you also have the width and the height, which would be the actual lengths. So I guess you have some point and then the lengths, and then whatever left, top, right, and bottom are. So top, let's look at left. So left says that X is equal to this thing, the X coordinate, I guess. And we have the width. And then we're going to take the min, NaN save min. So I guess like a mathematical min, but we don't have to worry about like not a number. So like division by 0 and stuff. And we're just taking the min of X and X plus W. So either X or the thing you get from X by walking out the width, whatever is smallest. That's on the left, and I guess that min is there to handle. Presumably, width is positive, so maybe the min is there to handle like reflection around the y-axis or something. And then similarly for top and right. For right, we're going to take the max, and for bottom, right structured clone. I'm not sure what makes it structured, but okay. So we're going to take JavaScript context and a clone writer and return a bool, probably maybe whether it's successful. And we can read structured clone. And a DOM-rect is, I guess, of type, or it extends the type read only, or a DOM rectangle extends the DOM-rect read only rectangle that we just saw, but we now have setters. We can set a layout rectangle. We can also have a rectangle list, which has an append operation where we just take the array and append the element. We can get the length of the list. I don't know why you need your own. I don't know why rect list has to have its own list. I don't know why rectangles need their own list implementation. And why not just have it for all objects? I guess it's nice to know that everything in the object is a list. But it seems like you could have a parameterized list. It does have length, but that's just the length of the array. Okay, so that's a rectangle. Is it worth looking at the, is it worth looking at the implementation at all? Just so that we see one? I guess we'll see if we can see one. I don't know what they call their C++ files. Maybe CC? No? Maybe CPP? Yeah? Okay, so here's the implementation. And it kind of just looks as you would expect. You've got, I guess, ref pointer, maybe a reference counted pointer. And round float, which will take a double and just call floor on the value plus a half. All right. Set layout rectangle. Okay, so we've got set layout rectangle, which is going to take a layout rectangle. This might be pretty basic because I think layout stuff in general uses rectangles. Because you can pack rectangles. It's harder for like a UI system to pack circles, let's say, or ellipses. So I think often things are laid out in a box, like a bounding box. In two dimensions, a box is a rectangle. Let me just verify that the chat is working as expected as well. Can I resize this? I'm very careful. I will get a resize button. I mean a resize. Almost. There you go. But it's kind of cut off. Let me see. All right, cool. All right. Yeah. Okay. So we've got this. What I'm going to guess is kind of like a bounding box thing. We've got the set layout rectangle, and we've got a scale which is 65536. Why is that the scale? And is this the same thing that we saw? But it's a float, or rather a double. This looks similar to what was it? 2 to the 16 minus 1. The maximum number of spreadsheet rows supported by Excel 97. Huh. Oh, it's exactly. Oh, it ends in a 6. So it's a 2. It's a multiple of 2, and it's exactly a power of 2. It's 2 to the 16th. Okay. So for whatever reason, scale is set to 2 to the 16, but as a double. Okay. Round to the nearest 1. Hey, round to the nearest 1 over scale units. We choose scale, so it can be represented exactly by a machine floating point. Okay. So scale can be represented exactly by a machine floating point. I'm realizing that I don't know exactly what floating point representation looks like. I know you've got the thing with like the abscissa and the whatchamacallit. We'll look at the floating point representation in a second. So scale inverse is 1 divided by scale. And T2P scale is scale over app units per CSS pixel. I feel like I want to know what CSS pixel is. Can I open this in a tab? No, I can't. But I will look at it. And then we're going to do some round the float and scale by scale inverse. And then we're going to set the rectangle. So scale inverse is 1 over 2 to the 16. And T to P scaled is scale. Okay, okay. Scale over how many units per CSS pixel there are, I guess. And then we're just taking the X and the Y and multiplying them by T to be scaled. And then by scale inverse. Okay. So T to be scaled has a scale in the numerator. And scale inverse has scale in the denominator. So if we weren't rounding and we were just multiplying this out, then scale over scale would cancel, and we would just be dividing by the app units per CSS pixel. Right? Is that right? That seems right. I'm not like doing the inverse of that, I don't think. And then, but with this round float, we're somehow first, we don't get the full power of this cancellation because we're rounding here in this rounding operation. So that's some math that's being done, maybe to align things to pixels properly, because pixels have this kind of discrete behavior where you can't really occupy a fourth of a pixel or whatever. I'm guessing why we're seeing it that way. Okay, so let's look at app units per CSS pixel. Go to definition. And it's just 60. It's the constant 60. Okay. So 60 units per pixel. Why? I have no idea. Maybe because it's a common refresh rate. Does that mean that we're thinking, like, does that mean that we can, in code, we can address a 60th of a pixel? And then when we, or whatever a CSS pixel is, and then when we actually render, but that 60 is there to like handle slop from the numerical computations, and then when we render, maybe we undo the 60th stuff. I don't know. I don't know enough about graphics code. Let's see if this Wikipedia article mentions floating point. No, I don't think so. Does it mention double? No. Here's floating point arithmetic. So here's a base 10 floating number, 12.345. This thing is called the significand. And then this is basically scientific notation. We're multiplying it by 10 to the negative 3. But I kind of want just a diagram of where the bits are. Floating point in modern computers. Maybe this is what I want. IEEE 754. Okay. Binary, single precision. I think we're dealing with a double precision, but let's look at single precision, which is, it says binary 32. So the base is 2. There are 24 bits devoted to the significand. So that's the significant figures, I guess you would call it. And then 7.22, that's decimal digits. That's base 10. And then there are 8 bits in single precision devoted to the exponent. So the max in decimal, I guess is what this is supposed to mean, is 38.23 for the exponent max, right? And then E-min and E-max. I'm not sure what E means. Decimal E, probably exponent. E-min is negative 126 and E-max is 127. Okay, and then in double precision, we get 53 bits for the significant figures and 11 bits for the exponent. And then I assume it's a pretty simple representation. So you just have those bits and then you chop the thing up and do the math with it. Okay. That was rectangle. Here's DOM quad. I'm guessing this is a quadrilateral. We can get a quadrilateral from a rectangle. As you would expect it, we get another from another quad. We can construct one. And to construct one, we need a global object and 4 points. That makes sense? They define a quadrilateral, and we can construct one from a rectangle. I don't know why we wouldn't just use from rect. But yeah. We can get the bounds, where the bounds seems to be just the different points that define the vertices of the quadrilateral. All right. So that's just some basic geometry stuff that is, I guess, on the lower level of the UI stuff. So here's navigator.h. And I don't know what sort of thing a navigator is, but it's got memory reporting. DOM fetch, navigator binding and nullable, credentials container, a clipboard. So we're much higher in the stack. We've got game pads and clipboards and stuff. So what is a navigator? This is DOM-based navigator. So this should be some way of navigating a DOM maybe, or having a DOM element that's used for navigation. So on navigation is called when the inner window navigates to a new page. I'm not sure what the inner window is, but maybe the inner window is this thing that has the web page. So when we navigate to a new page, on navigation is going to be called get product. I'm not sure what product is. Get language, app name, app version, get platform. Presumably things like Windows versus OS X or whatever. Or Mac OS, I think it's called. Can share. I don't know. I guess maybe share between something, maybe share between threads or processes. Vibrate. That vibration permission. Maybe vibrate is for gamepads, because we saw a gamepad as a class that was mentioned. Cookie enabled. Get gamepads. Finish get VR displays. Maybe I guess VR support. Send beacon. Who are we sending beacon to? A URL. So I guess when you navigate somewhere, you can send a beacon to somebody. Maybe is this for like phoning home? Moz get user media. And then we have a service worker JavaScript, credentials, clipboard, GPU, and locks. It's a whole bunch of stuff. It's kind of interesting. So we've got, I guess it's not so unexpected you'd have locks at a higher level in the stack, I guess, because you need to guard access to things. We have we can get so autoplay policy. This is, I guess, stuff like if I tell Netflix, I think is one of the offenders, will just autoplay stuff. And this, you can tell Firefox that you don't like that behavior, and it will, I guess, enforce it. And presumably this is here for that reason. Get VR display update. I had no idea Firefox had native VR support. I guess it's not surprising. I don't own a VR headset, but I suppose if you wanted to, you could browse the web in VR. And that's there, right? Because there are game experiences and presumably VR experiences that are served over the internet, and Firefox wants to support them. And then things like plugins, geolocation, battery manager, more clipboard stuff, whatever M window is. If we look at this window type, NSPDOM window, PI-DOM window. We're going to include NS-IDO window, IDO-M window, and Moz-IDOM window. Maybe we'll go here because this is generated. So Moz-IDOM window seems to be generated code. What about this one? This also seems to be generated. Shall I look at let's just look quickly at the generated code. Do not edit. This file is generated from dom/base/Moz IDOM window IDL. Well, let's look at this thing. Oops. I clicked on the wrong component of the path. There we go. Okay. Placeholder interfaces to allow passing inner routing windows through XPIDL. IDL should be interface description language. XP cross-platform or Windows XP. I don't know. And then this is really simple. We've got some UUID, and the interface just says Moz IDOM window. It probably is of type NSI supports. I have no idea what NSI supports is. NSI supports a runtime mechanism for interface discovery. So we have parameters: a requested interface ID, a pointer to an interface pointer to an interface pointer to receive the result, and returns NSOK if the interface is supported by the associated interface. That's query interface. Let's search for NSI supports. XPCOM. XPCOM components in Rust. The following example shows a new type that implements NSI observer. Yeah, but what is it? Let's ask one of the bots. Yeah. So I'll ask ChatGPT what NSI supports is. Provides generic support for various objects in the system. It is part of the XPCOM cross-platform component object model architecture, which is the underlying framework used to build the Firefox web browser. NSI supports is a fundamental interface in XPCOM, and all other interfaces in XPCOM are derived from it. It defines a set of methods that allow objects to be queried for their supported interfaces and to be reference counted by the systems. Okay, I guess supports is means because you can ask it what it supports, so it can be queried for its supported interfaces. And we've also got this reference counted thing, so they get reference counted. In simpler terms, NSI supports is a base interface that provides a way for objects to communicate with each other in the Firefox codebase. That just sounds like IPC though. It allows objects to identify the other interfaces they support and provides a way to manage the memory used by these objects. Okay. So something about kind of IPC service stuff that I will just black box for now. So here's node info, dom/base/node info. We get this NS cycle collection participant. I still don't know what NS is. Not Mozilla anything. Namespace? We do see namespace constants. Okay. So we can get the name of the node. We can name atom. Get the name of this node as an atom. I don't know what an atom is. We can get the qualified name, node name, lots of name stuff. We can get its prefix, the namespace ID. Get the namespace ID for a node if the node has a namespace. If not, this returns k namespace ID none. We can get the node type, which is a uint16. And a bunch of other stuff. We can check whether things are equals. Utility functions that can be used to check if a node info holds a specific name, and prefix. Okay, we can get document. Retrieve a pointer to the document that owns this node info. It's going to return a document star. Here's node info inner. This is basically, I guess, a class to contain all this information. And node info manager. Yeah, let's look at document. Here's the document interface. This is implemented by all document objects in Gecko. So the document class, you give it an NS inode, a document or shadow root, whether it supports weak reference. Oh no, these are things. No, these are things that it is extending, I guess, as a class. I guess it supports weak reference. It's document or shadow root, etc. Is radio group container. Is script object principal. Dispatcher trait and supports weak pointer. Okay. And what else? You can create one from an old one. And its friend class is document or shadow root. We've got some defines here. If NS document notify observers. Okay, so I guess you can have observers to a document, and this is some like template to handle notification. It's going to call it NS observer array notify XPCOM observers. So this is more XPCOM stuff. And this is maybe similar in spirit to some of the cute stuff we saw for signals and slots. Here's radio group stuff. It has a string and a visitor. Maybe we're using the visitor pattern. We're going to return document or shadow root walk radio group with the visitor. Cool. Let's look at this document or shadow root thing. So here, when the document or shadow root walks the radio group, we're going to get or create the radio group from the name that we were passed. So we're passed in a name and not the radio group itself. So we have to get it. And this is something that I think is similar to, I recognize from doing Android development, where you have like a string ID and you call like find by ID or something similar, and you kind of like inflate the actual object, or you look up really the object in some table from its ID. And then we're going to, we have a for loop where we're just walking over the radio buttons and calling a visitor visit. Oh, no. If not a visitor visit, return OK. And then return OK. So maybe visit returns false. Okay, so we're just going to walk over the stuff and call visitor. And we're going to say it's OK if this returns false. Wait. Yeah. Okay. So I guess it returns true if there's an error. Is that right? Something like that? All right. We can set current radio. Okay. So that's the visiting logic. So that's radio group. But where is what I really wanted was the document root class, I guess. Document or shadow root. Document or shadow root is just, I guess, a new class kind. You have a document or a shadow root. And kind document is I guess it's just defining like the name. And what can we do with these things? Well, we can create them, we can traverse them, and give it a callback. Unusual argument naming is because of cycle collection macros. So there's some cycle collection macros. I don't know what is supposed to be unusual about the naming. I guess temp and CB. So you pass in a document or shadow root and a NS cycle collection traversal callback. So maybe on every, as you're traversing, this thing gets called on every node or something like that, and we can unlink. We can, I guess, cast it as a node. Sheet at, I guess, will give us the style sheet for a document. I think. Yeah, that's what we're doing, right? Okay. And we can adopted style sheets. We can, I guess, adopt some style sheets. And this is just like a getter for the adopted style sheets. Where's all this stuff defined? I'm not sure. Okay. This looks like the real document thing. Add ID target observer. Add an ID target observer for a specified ID. The ID target observer will be fired whenever the content associated with the ID changes in the future. If A4 image is true, modset image element can override what content is associated with the ID. In that case, the ID target observer will be notified at those times when the result of lookup image element changes. I don't know what the ID target whatever is. Lookup image element. Look up an image element using its associated ID, which is usually provided by mods element. Okay, so this is the document stuff, and we're getting style sheet stuff as well. Okay, so that's... So what have we seen so far? We've seen some rectangles. We've seen some quadrilaterals, kind of geometry stuff. We've seen what appears to be the document, the notion of an HTML document that's handled by Firefox. And that's a relatively abstract interface that has things like the ability to walk over it and execute callbacks or execute visitor functionality. And we saw, I forget what it was called, but we saw the thing that had Oh, the navigation thing that had a bunch of higher level stuff like game pads and a lot of the more user facing stuff in a browser. So here's Visual Viewport. Here's the spec. Let's click on the spec. The Visual Viewport represents the visual viewport a document is being presented in is if it is fully active. Each window in a page has its own distinct visual viewport object. A document being presented in any browser context, including a nested browsing context, will have its own visual viewport. For example, if a script retains a reference to a visual viewport or for an iframe, then navigates the iframe to another location, reading the integral values from the visual viewport reference will return 0 because its Windows document is no longer being presented in a browsing context. It is no longer fully active. A visual viewport is a kind of viewport whose scrolling area is another viewport, called the layout viewport, whose scrolling area. The term scrolling area refers to a box of a viewport or an element that has the following edges depending on the viewports or elements scrolling boxes or overflow directions. For a viewport at the top edge of the initial containing block, all right, this is kind of more down in the weeds. So putting aside iframes and stuff like that, I'm going to consider this whole thing that contains the web page to be the visual viewport. Okay. And we've got things like left offset, top offset, page left, page top. And we can wrap the object in JavaScript. We saw that before. We've got what seem to be callbacks for resize events, post resize event, post scroll event. And if you're going to scroll, we've got the two things. Visual offset and layout offset. And visual viewport resize event has this code comment. These two events are modeled after the scroll event class in whatever this thing is, ns graphics scroll frame.h. Okay, and we have this CSS size thing. We've got two CSS points for the offsets, a document, which we just saw, press shell, maybe presentation shell, and pres context. Okay. If we look at the implementation, I'm not sure. Oh, this is going to be exciting. Wait, didn't we decide that CC was how they did it? Was it CPP? Yeah, I just remembered incorrectly. Okay. Get event target parent wrap object visual viewport size. Let's look at visual viewport size. We're going to set the CSS size to 0. I think, unless that's like the CSS size of the origin. Flush layout, as that may affect the answer below. E.g. scroll bars may have appeared, decreasing the available viewport size. Okay. Kung Fu Death Grip. What? We have to look at Kung Fu Death Grip. Oh, is this just the name of the pointer? Yeah, okay. All right, if document, so we're going to flush pending notifications. So I guess process everything that's pending in case we like scrolled or whatever. Then we get the presentation shell and we check whether it's visual viewport size set. And if so, we get the dynamic toolbar state. And I guess the state can either be in transition or collapsed. And depending on that, we either get the visual viewport size or we get the visual viewport size updated by dynamic toolbar. And that gets it set to size, and then we ultimately return size. And then there's this other condition where we handle similar stuff. So that's just a kind of like a flavor of what the logic looks like for all this stuff. I think for a lot of this, once you have the types worked out properly, the implementation looks really simple, and then the complexity is in what is the relationship among all of the types, and how do you get them to change properly so that things are propagated correctly. Here's window features, which I opened just hoping to find window stuff, but I think we've mostly found window stuff. So I'm going to ignore this. Here's XPath generator. I'm just kind of curious what's going on here. It says return a properly coded string, insert into an XPath, quote argument, escape name, and generate. Okay, nothing interesting, at least in the header. Here's tree walker. And we've got root, what to show, get filter, current node. I guess if we're walking the tree, we have some current node. We can set the current node. And all our traversal methods return strong refs because filtering can remove nodes from the tree. All right. We've got parent node, last child, first child, previous sibling, previous node, next node. Lots of tree stuff, as you would expect. You can wrap it in JavaScript. First child internal implements first child and last child, which only vary in which direction they search. Okay. And then next sibling internal. Cool. So this is tree stuff. It's tree algorithms, as you would expect a browser to have, since so much of the layout stuff is done with trees. Here's UI Direction Manager. No idea what that is, but maybe it's things like whether you've rotated your phone or whatever. Here's style sheet list.h. I don't know if we care about lists of style sheets. Do we have style sheet.h? See if we can find a reference to here, class style sheet. So we've jumped to source/layout/style/style sheet. We've got a style sheet parse promise. I guess we're going to parse the style sheet and it's going to return some promise. So we're like that's for asynchronous parsing. We've got servo ss rule list. Here's style sheet state, which is some enum. It tells you whether it's disabled, whether the sheet is complete, it is finished loading, whether we're forced to unique. I feel like we might have looked at this file before, and whether rules are modified for dev tools. And then a style sheet as a class takes a parsing mode, a cores mode, which should be cross something request something. Let's look up cores. Cross-origin resource sharing. It's a mechanism that allows restricted resources on a web page to be requested from another domain outside the domain in which the first resource was served. Okay, so that's cross-origin resource sharing. I guess so that you can use, maybe so you can use style sheets hosted elsewhere. Where was I though? Oh, here. The wrong line was highlighted. Okay. So if the cores mode, SRI metadata integrity. I don't know what that is, but I'm going to ignore it. And then we can construct one with a global object, a style sheet init, and I guess error result is probably a something that's passed back, maybe a boolean about whether it has rules. I don't know why you would not have rules. And then you've got parse sheet, which parses a style sheet. The load data argument corresponds to the sheet load data for the style sheet. Finish async parse and parse style sheet, reparse style sheet. And then stuff about whether it's loaded. I'm not sure where. Let's pull this out. Maybe we can find the code where the parsed style sheet is actually applied. Here's base selection, but we'll get back to that later. I'm going to finish like working through this queue of tabs first. Note the ownership of Mozilla ::dom : selection depends on which way the object is created. Okay, so selection extends support weak reference, wrapper cache, and support weak pointer. It's going to take a selection type and a frame selection. What are the selection types? So we've got some stuff about batch changes. Get parent object, get dog object, scroll synchronous, scroll first ancestor only, scroll do flush, overflow hidden, dispatch event, remove collapsed ranges, get range at. This is selection. Some web IDL stuff like get anchor node, anchor offset is collapsed. Is the whole selection just one point or unset? Whether we can run scripts. JS methods are mapped to selection.star. They may move focus only when the range represents normal selection. They shouldn't be used by non-JS callers. We can flush frames, check whether it contains a node, indicates whether the node is part of the selection. So if you select some stuff, it might contain a node, and you want to know whether the selection is contained. A collapse in limiter collapses the selection to a single point at the specified offset in the given node. When the selection is collapsed and the content is focused and editable, the caret will blink there. All right, cool. We'll just move along. I'm trying to be a little bit, maybe not have this one be as long as the other ones, but there's a ton here. So we're just going to do a quick little tour. Here are scrolling metrics, which we're seeing some callbacks, like on scrolling interaction ended, get singleton. That's not a callback, that's just getting a singleton. But what else? Collect local scrolling metrics, return the... I don't know why they need scrolling metrics. Scrolling metrics records user-initiated scrolling interactions. These are aggregated along with other user interactions, for example, typing view time in the history metadata. So maybe this is something that's reported back to Mozilla. Mozilla has, I've seen talks about, from Mozilla, about they've done some work on privacy preserving telemetry collection. I don't know if the scroll metrics are part of that, but they do collect telemetry. You can turn it off, but they have some way of doing it privately, or at least they're working on a way of doing it privately. I don't know if everything they've deployed is private in that way. Okay, so here we are with Chrome. I'm going to mostly ignore Chrome, I think. Here's HTML. And we get a bunch of files for HTML elements, like different elements. Let's just pick one victim. Something simple and classic, maybe anchor. And we'll just look at its header just to get a flavor. Okay, so an HTML anchor. In which languages do you write code? I've written, let's see. I've written code. I think Google counted for me. I don't remember how many before I left that I had like committed code in, but I think it's somewhere between like 15 and 20 that like just at Google. A lot of that would be stuff like HTML and Markdown. I don't know if you really want to count that stuff. But the main things that I write code in, I've answered this before, like a version. But some things that I've used a lot of are like C++, Python, Go, R, and there's probably some other stuff in there. Those might be the main ones. I've also like played around with a bunch of other stuff like Haskell. Oh yeah. Hi, Darren. That's in my bio. I don't always know if people sometimes yeah. So I've those and then Java and Kotlin and those sorts of things are like the classics, but I've also played around with like JavaScript and Dart, and so that's what I've been up to. What do you guys program in? Are you guys all programmers or aspiring programmers? Be curious what people are up to. Okay, so where are we? We're an HTML anchor element. Oh yeah, no. Oh no. There's a sorry, new follower. I've dipped in and out of your streams. Yeah, yeah. Oh, thank you. I something I'm new to it, new to this. I forget. You know, I kind of just forget how much context people have, and things have grown so much. So for like a while, it was like a couple of people I would see frequently, and so just sometimes I forget. So my apologies. I didn't mean that you should have like you should have known that. Um, but yeah, so yeah. But thanks for stopping by. I mean, it's super cool that this is of interest to people. Um, it's kind of this sort of reading code stuff. Okay, so we have this anchor element, and we're going to keep track of whether we've already reference counted it, I guess. And it's some node info. It's, I guess, why is it not a node? I don't know, but maybe it's kind of like the info contains like a pointer to whatever the real node might be considered. And we've got this, this is like I think we're like constructing stuff, right? So we're going to standard move node info um, into this thing. And then we've got this link thing. Yeah. Okay. Anchor, right? Yeah. So this should be like links. Oh, okay. So link is something that we're passing in. Okay, and it's an explicit. The link of this. Cool. And I don't know what a link is, but we can kind of presumably it has a URL, maybe some other stuff. Is interactive HTML content, bind to tree, so we can bind it to the tree. And we give it a bind context and a parent. And I suppose we'll attach it to its parent. I don't know what a bind context is, but something that's used for the tree. We can unbind it. We can decide or tell it whether it's focusable. I guess focusable will take a with mouse is focusable in a tab index and will return a bool. I guess that's a like a predicate, like we're querying whether it's focusable. Set attribute. I'm sure a bunch of this stuff looks like this is probably for all sorts of elements, like whether it's focusable, binding it to tree, get and set attribute. So this is just stuff I would expect to see everywhere. Get link target it sounds like it might be specific to anchors. Get href URI, get href, set get ping. I'm not sure what ping is doing. I don't know if it's like pinging the URL. Set ping, get rel. I don't know. Refer policy, get type, and then a bunch of comments. Set car set gets that node info changes. Okay, cool. That's just one element. I think we'll leave it at that. All right. All right. What else do we have? Okay, so we have XHR. This is like XML HTTP request. Well, I don't think that's so UI related. Here's XML. This might be UML. So here's an XML document. An XML style sheet processing instruction. Let's look at these two. Here's XML style sheet processing instruction first, I suppose. It's going to take a processing instruction in a link style. We're going to check whether we've already refed it. And all right. You can set node value internal, bind to tree, unbind from tree, override base URI. This tells the processing instruction to use a different base URI. This is used for proper loading of XML style sheet processing instructions. Yeah, I don't know what this is doing. What's the processing instruction? Let's see that. It's got character data. So maybe it's basically a string. And we're going to take node info and this NSS string. So some string, essentially, a fancy string. And what are we going to do with it? Let's get target and get the attribute value. I don't know. Hey, what does it do? I guess, what was it? I think it was CPP. We can list some stuff. Okay, yeah, I don't know what processing instruction. Oh, get sheet for bindings. Use XML document.h. there's some noise here, so that's why I'm pausing. Okay, so the check whether the channel is pending, whether it's a plain document, suppress parser error element, and more console message stuff. mChannel is pending indicates whether we're currently asynchronously loading data from mChannel. It's set to true when we first find out about the channel. Yeah, there's not a lot of behavior to this document, but that's okay. I'm going to ignore XUL and SLT. This one might be. Let's look at one of these. Let's look at tooltip. Do you want to look at tooltip? Yeah, I guess so. So this is XUL. So this should be part of the XML thing that Firefox uses to render, or rather to describe, to like declaratively describe what UI should look like. And there's not much here. Post handle event. I guess once you handle it, you can have a callback. You can set an attribute and you can init it. So that's the header. And then init. Let's look at init. Init short. Create the default child label node that will contain the text of the tooltip. This is the tooltip. Like a tooltip is the sort of thing where you hover over it and it's got like a pop-up to give you more context. So we're going to get the node info. And no, we're declaring the node info, and then we're getting it by calling get node info and passing in some stuff like a description or whatever. And here's, I guess we're declaring a description. Then we're going to call it new XUL element. So we're creating a new XUL element with the description, something about forgetting, and some, I guess, enum. This is not from parser. NS ensure success. So we're going to do some NS stuff, which is, I think, the kind of IPC stuff they have. And ensure success might do something like fail badly. If it, if it returns false, it might do something like bail out aggressively. And then we're going to set attribute with no namespace. Something about the atoms class. And we'll have this tooltip label and whatever false is in set attribute. And then we're going to declare an error, append child, possibly with the error, but the error is basically empty or null, I guess. And then we're going to return error steal NS result. I don't know what that is, but presumably we're going to return whether we are successfully able to steal stuff over IPC. And then after set attribute, we have some implements some callback. Post handle event is going to take a visitor, an event chain post visitor. So we're going to take a visitor and check if we're going to check the message, and if it's equal to pop-up showing. So the tooltip is a kind of pop-up, I suppose. I mean, it is a kind of pop-up, but I suppose that's what this pop-up is, rather than like a window pop-up advertisement like you get in browsers. I think it's more likely to just be whether the tooltip is showing. And then we're going to check whether the event is trusted, I guess, and whether the visitor event is not prevented. And whether the attribute value, something case matters. Okay, so page and title tip are how these two things differ, but otherwise they kind of look the same. So something about pages, something about title tips. These are like the last, and not title tip, I guess. These are the last conditions. So if all this stuff is true, then we do some stuff. When the tooltip node has the page attribute set to true, the tooltip text provider is used to find the tooltip text from page where mouse is hovering over. All right? So the text provider is something we fetch from somewhere, from do get service ns default tooltip text provider. So this is some service lookup, it looks like. And then we have a text and a direction. Whether we should change is set to false. And if we successfully have a text provider, then we're going to get the node text and whether we should change. And if we should change, we're going to set the attribute of the label. And we're going to, we're going to set the label and we're going to set the direction. Otherwise, we're going to consume no default, whatever that means. And we're going to prevent default and return OK. So I don't know exactly what all of that is doing, but that all looked plausible, like plausible code. And then here's documentation. I'm going to close out that. And then I had opened this style sheet thing. I was kind of hoping to see a little bit of where Firefox understands a style sheet and applies it. But I'm not, where are we? We're about an hour and 20 minutes in. I'm not going to look too much for this, but I will take a quick look. Here's CSS. That's CSS.h. I guess let's take a quick look at. Import rule, keyframe, media rule, page, document style root iterator. Document style root iterator traverses the root to the document from the perspective of the servo-backed file system. That might be relevant. Generate C process, image loader, loader.h, media list, NSCSS value, font face utils, style struct, preference sheet. I guess maybe let's look at, wait, did that work? Let's look at one of these font face ones. Font face implementation, that looks promising. So here's css.h. This is just the header file for CSS. And we've got whether it supports stuff, whether it supports some other stuff, and escape. And get highlights. Get highlights. Returns a highlight registry. I'm just curious what a highlight registry is. Highlight registry manages all highlights available to a document. This class is exposed via highlight registry web IDL and used to add or remove highlight instances to a document and binding it to a highlight name. The highlight registry IDL interface defines this class to be a map-like. To be able to access the members of the map-like without proper support for iteration from C++, the insertion and deletion operations are overridden and the data is also held inside this class. All right. Okay, so here's font face implementation. And we have a bunch of font face stuff, font face buffer source, font face descriptors, some thread safe ref counting. Okay. Graphics user font set. So we have some font set, an array, font set source list, font attributes, font entry, some kind of mutex it looks like. We can set load state, get user font sets, check user font set, add font face, remove font face, these take implementations, font face impls, which I thought this is the class we're in, right? Font, which owns this entry. So there's some font that owns this entry. And some more font face stuff. Get owner, create for rule, get rule. It's a raw servo font face rule. Get attributes. We can check whether the, let's see. Returns whether this object is the specified font face set. So is font face set? Get family name has rule, disconnect from rule has font data, get data. And then here's web IDL stuff. Get family, set family, get style. Set size and adjust. Font face implementation. Do load, helper function for load, update owner promise. Set descriptor, helper function for the descriptor setter methods. And we can set status. Take buffer, returns takes ownership of the buffer, storing the font data. And we have some source type, font face rule, URLs, buffer, source type. And then let's look at the implementation. See if we can find out where it actually applies a font face. Assert is on owning thread. Okay. Initialize source URL. So I guess you can give it a URL. And what does it do? Ignored error result, set descriptor. If rv.failed, what's rv? I guess error result. This is just a setter. So set family, we're going to flush the user font set. And then call set descriptor. And then call descriptor updated, which sounds like a callback. Where's set descriptor? Fix me. Okay, Boolean result indicates whether the value of the descriptor was actually changed. That's the sort of comment where you probably actually don't need it, because what else is it going to do? That's such a common pattern that it may not be a necessary comment. I just thought I would point that out because I'm often saying that I want more comments. And then there are some people who are like really against, comments because they think everything is obvious or whatever. But too many comments probably hurts if you have a ton of them. But for the most part, usually doesn't hurt. I don't think this comment hurts anything. But if you were worried about having too many comments, this is the kind of comment that I think is pretty straightforward. I think most programmers could figure out that if you return a Boolean on a setter, that's usually like a success condition. Sometimes true means failed, which is maybe then you want to comment saying that if you get true back, that means it was unsuccessful or whatever. Okay, so fix me. We probably don't need to distinguish between this anymore since we have a common backend now. And then this is some error. We don't handle rule-backed font face objects yet. Okay, this should only happen in worker threads where we failed to initialize the worker before it was shut down. If we get URL extra data, and something about worker threads. Okay. And then we're just servo font face set descriptor. So we're actually calling out to this other thing. Maybe I guess lower down in the stack. Yeah, is this Rust? This should be Rust. Parser context, new, origin author. Right locked arc worker. So this is lower. This is lower down the stack. Okay, we'll take a quick look at this. I don't really read Rust, and I now don't have the context of what's exactly going on in servo. Yeah, okay. So right locked arc worker. It takes, I guess we're gonna give it a rule and something about I don't know if these are notations on the rule. I'm not sure what this means. But macro rules to CSS text. I guess if valid, then we have this condition. We set some field, it looks like, or we call ident. I don't know. And if it's invalid, then oops. If it's invalid, then whatever this stuff is. And I guess we're going to call match on desk, which might be description. So maybe we're doing something with a name, some sort of condition on the name. If let OK value is parser entirely parse blah, 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 then we'll get some result. We'll get a result from sum of value. Maybe sum as opposed to maybe as an optional. And then We'll check whether result is equal to our to rule dot field. And if it's not, then we'll say that out is changed and we'll set field to result. And I don't know. Yeah. So this is, so I guess they are, so they're using servo, they're using the Rust code, I suppose. More than maybe I thought they were. But we'll quickly scroll through this glue gecko lib. This is some sort of, I guess, glue between gecko and servo. So let's take a quick look at it, and then I guess we'll call it a day. We're importing a bunch of gecko stuff, as you might expect in glue code. Do we get a comment? For gecko to server function calls, we need to redeclare the same signature that was declared in the C header in gecko. In order to catch accidental mismatches, we must rust bingen against those signatures as well, giving us a second declaration of all the servo underscore star functions in this crate. If there's a mismatch, LLVM will assert an abort, which is a rather awful thing to depend on, but good enough for our purposes. Then we've got a bunch of no mangle annotations. I'm not sure what that means, but maybe it means maybe there's mangling that the compiler might do, and we want it not to because we want C and Rust to know about each other's symbols or whatever. And we've got, let's look at servo initialize. I don't know why we have dummy URL data. Gecko binding sugar origin flags. Thread state, initialize some thread stuff. Pretend that we're a servo layout thread to make some assertions happy. Okay. Perform some debug only runtime assertions. I don't know how we know that this is debug only. And then we've got this dummy stuff. Yeah, I don't know. So I'll leave it at that. Maybe we can see if we can find gecko under source. Nope. Wait, how's this not a URL? We'll do a quick search for gecko. Hi. Hi, Stepan. There's too much stuff for gecko for me to find it quickly. So I'll leave it there. So what did we learn? The original question I got was like, how do browser UIs work? So that's I took that question fairly literally. And so we kind of looked at a bunch of stuff that's around the rendering of the UI. We didn't look at the whole stack, obviously, but we at least touched on enough that if you're interested in digging in further, you should be able to dig in further. So we saw some of the stuff about windows and documents and the logic that kind of iterates over things. We saw a little bit of CSS logic or definitions classes. We saw some stuff about layout rectangles, or at least it seemed to be about layout rectangles. And then we didn't really get into gecko or servo, but they started like cropping up their head a little bit. And then gecko and servo would be the optimized, I think, like lower level engine stuff that ultimately gets called when most of the code we looked at is done kind of setting up its work. Yeah. So if so that's that. If you're programming and trying to like change trying to change the UI, that's more of the code we looked at today. And then my guess is that if you were looking closely at gecko or servo, it might be hard to translate like the stuff that you're seeing directly as much to like what would be shown on the browser screen. So at some point we might look deeper at that level, but in the interest of not making this like a 3 hour long video, I'll leave it there. And I'm seeing a thing on the chat. What do I think about the idea? But sometimes they say contribute to some of them, fix bugs. That's an interesting idea. We're gonna build some stuff here. I don't think I have the bandwidth to like, you know, contribute to a wide variety, certainly, of open source things. So we may do some of that kind of like incidentally, but I don't think, at least at this point, that that's going to be something we do regularly. I do think that's a good idea. I do think somebody should do it. I'm not able to do it at this point, just because I have other stuff going on. So, all right. Well, thanks everyone, and have a good weekend. Thanks for watching.